Section 5.1 is systems of equations. When we're given two equations, they're going to ask us where's the point that these have in common, and you're going to have one of these three possible solutions and the situations related to it underneath it. So you're either going to have one solution, no solution, or infinitely many solutions. This is what they look like graphically. On the next page, we're going to talk about how to solve for these algebraically, using specifically the elimination method. Now, we either want to eliminate one of our variables. We either focus on our x and eliminate it, or we focus on our y and we eliminate it. So, in this first one, I'm going to mostly look at the x values. To eliminate something, I need them to have the same coefficient out front. I need one to be positive and one to be negative. So first of all, it's kind of like reciprocal. I'll multiply the first one by 4, and I'm going to multiply the second one by 6. One needs to be positive and one needs to be negative. Okay, so now when I look at this, if you look, I've flip-flopped these two right here to be able to get multiples. So now that when I multiply this, I'm going to get 6 times 4 is 24x minus 4y minus 20, and then I'm going to get minus 24x plus 12y minus 36. Okay, once I distribute, now I want to add down. My x's eliminate. That was my goal and that was my purpose, and that's why I chose these coefficients out front to multiply by. So we continue and we get 8y equals negative 56. Continue to solve. Y equals negative 7. Now I have one value. I need to go back and solve for my x value. So I start with either one of the original equations. I'm going to use this first equation, which is 6x minus y equals negative 5. And this time I'm going to substitute negative 7 in place of y. So I'm going to add my inverse here, and I have 6x plus 7 equals negative 5, and I continue by solving. 6x equals negative 12, divide by 6, divide by 6, and x equals negative 2. Now I write this ordered pair, the x value, then the y value. This is the solution. It is one solution. It's consistent. If we look back, it's consistent and independent, and it's the ordered pair negative 2, negative 7. My next example has fractions on it, so let's move that out the way. First of all, I want to get rid of all my fractions. If I look at equation 1 and I find a common denominator, I'm going to multiply everything by 12. So I can get rid of the fraction. First step, let's get rid of the fraction. Divide by 3, divide by 3. Now I'm going to multiply. I'm going to get 4 times 2 is 8x. Divide by 4, divide by 4. Now I'm going to get 3 times 1 is 3, keep the y. My last term, divide by 2, divide by 2. Now I say 6 times negative 3 is negative 18. In my bottom equation, a common denominator is going to be a 4. So if I multiply everything by 4, then I'm going to get divide by 2, divide by 2, so I get 2 times 1x is going to be 2x. This 4 cancels this 4, and I get minus 1y, and then 4 times negative 2 is negative 8. Alright, now I want to look at these two. Last time we eliminated the x values. This time I'm going to choose to eliminate the y values. You have that order. You have any preference that you want to choose. So our focus, for something to eliminate, one needs to be positive and one needs to be negative, so we're good there. And they need to both have the same coefficient here. Well, this one only needs a 3, so I'm going to multiply this whole equation by a 3. I leave equation 1 alone. And then this one I distribute. Negative 24 Add down, I'm going to get 14x equals negative 42. Divide both sides by 14. And x equals negative 3. Well, you can go back into either one of your original problems. Now, there's fractions there. So we have 2/3 x plus 1/4 y equals negative 3 halves. Now, I want to substitute negative 3 in place of x and solve. So I'm going to continue doing this. If I put this over 1, these cancel and I get negative 2 plus 1/4 y equals negative 3 halves. Add 2 to both sides. So I have 1/4 y equals 1/2. Multiply by the reciprocal, which is 4 over 1. 4 over 1. These cancel, so you get y equals. Cross cancel here, and you get 2. Our ordered pair is negative 3, 2. It's also one solution, consistent and independent. Our last example, we're just going to look at this. Let's eliminate our x value. One needs to be positive and one needs to be negative, so the signs are already opposite. I need them to have the same coefficient. This equation needs a 3 here. If it has a 3 here, then you'll see they'll eliminate. So if I multiply equation 1 by 3 and distribute, that gives me negative 3x plus 9y equals 18. This one leave exactly the same. 3x minus 9y equals 9. When you add down, these cancel and these cancel, but I have to have 0 as a placeholder. So I get 0 equals 27. That is a false statement, and since that is false, our answer is that, which also means no solution. Now, if I saw a graph of these, they would be parallel lines back in the beginning. That's this system, this equation right here. So that's what's going on when we look at these. So this is one of our special cases.